load line. So now we are going to discuss a very, very serious issue in BJT. So I have highlighted this in the previous classes. BJT has this issue called as thermal runaway. Thermal runaway, as the name indicates, can anybody say what is meant by thermal? What is the significance of the word thermal? Thermal means
Heat, sir. Heat capacity.
heat. In another technical way, how can you call thermal?
Temperature.
Temperature. Very good. Runaway. What is running away? In this thermal runaway, what is running away? Something is running away. That is what is mentioned. Thermal runaway means because of temperature, something is running away from BJT. What is running away? Can anybody guess? Q point. Yes. See, all the beautiful names they have given in BJT will have significance. It is just not like just for fun they have given runaway. Thermal runaway means because of the temperature, Q point is running away from the center. So that is a serious issue in BJT. So we have seen the expression for collector current. So this is, the expression IC equal to beta into IB plus ICE naught. So I can write this ICE naught in terms of saturation current as beta IB plus 1 plus beta into IC naught. So three parameters we told which are going to affect the temperature, which are being affected by temperature in BJT, right? One is beta, the current amplification factor. Second one is VBE. Instead of VBE, we are including IB because VBE will constitute IB, okay? And IC naught. IC naught is the reverse saturation current or the reverse leakage current. Among the three parameters, which one will be affecting your current in a larger way is going to be this IC naught. Among the three, this IC naught is going to affect the performance of your BJT a lot in a very broader sense when compared to beta and IB because it is doubling with every 10-degree rise in temperature. Okay, it is doubling. It is not increasing by one time or two. It is not increasing in a linear way. Linear way means it will increase slowly, but it is multiplying by 2 every time. As the temperature is going to increase by 10 degrees Celsius, it is going to double by 2. So for 10 degrees, if it is doubling by 2, for 1 degree, I can say it is multiplied by 0.2. So for every 1 degree rise, the IC naught is multiplied by 0.2. Okay, or for 10 degrees, it will be multiplied by 2. So I can interpret it in that way. So among the three culprits, what we have seen, beta, IB, and IC naught is going to be ruining the performance of your BJT. So because the collector current initially when temperature is going to rise mean the collector current will rise. When IC is increasing, IC naught will increase. When IC naught is increasing, it is like a feedback. IC will again increase, so which will raise the temperature of collector base junction. So when the temperature is increasing, the collector base junction is most reverse biased, right? So the reverse saturation current will be doubled. When IC naught is doubling, you see in the equation, IC is having a component called IC naught. And IC naught is multiplied by 1 plus beta. Beta is very, very large. So this product will be increasing lot. So when IC is going to increase in a larger scale, your transistor will no longer be in active region. When current is increasing in abnormal way, the transistor is heading towards saturation or cutoff. The transistor is going towards which region? When the current is increasing in an abnormal way. It is saturation or cutoff?
Saturation, sir.
Saturation, yes. And the Q point is moving upwards or downwards?
Upwards.
Upwards. Very good. See, that is the interpretation you have to understand. When a single parameter is changing, you should immediately say whether the transistor region is changing or the Q point is moving upwards or downwards. So when the collector current is increasing, the transistor will be slowly moving from active region to saturation, and the Q point will be shifting from the midpoint of the DC load line. It will be moving slowly towards your y-axis. That is a danger mark because when large amount of current is going to flow through your device, it may leads to eventual